A delegate is a data type that references a function or method. Consider the code that defines a delegate called getBig. We have added a delegate keyword before the function signature. The delegate getBig can hold any function that matches this signature, can hold any function that returns an int and accepts two int type of arguments. Next, we have added a function called getGreater, that returns the greater of the two arguments passed to it. After that, we have added another function called higher that too has the same matching signature. It might include a different logic to determine the return value, but the point is that both the functions they have the same signature. So we have two different functions of the same type, each accepts two ints and returns an int. This means that the delegate getBig can point to either of them. This is important. Inside main, we have declared a variable fx of delegate type getBig. And next, we ask the user to type 1 if the function greater is to be called. If the user enters 1, then the fx, it contains greater, it points to greater. The function greater is compatible to fx, so fx can point to greater. Otherwise, fx points to the other function called higher. And finally, the delegate type fx can be called by passing two arguments and storing the return type in an int type of variable. So whatever fx contains, that logic executes, and this is a runtime story of calling a function. Hence we can see that delegates are data types that hold functions of a compatible signature. Next, let's see lambda expressions. Lambda expressions are used to create anonymous functions. Consider this lambda expression that specifies two input parameters. Notice that they are specified on the left side of the lambda operator, equal to greater, and we can call it goes to. So the two inputs they reside on the left side of the operator, and the compiler can infer their data types from the context of use. The body contains just one expression and it is towards the right of the lambda operator. Such lambda expressions are called statement lambdas because they consist of just one statement. No return statement is required because the compiler can infer the return type in this case. Let's write the previous program using lambda expressions now. We have done with lambda statement and now we will do it with lambda expressions. First of all, we have defined the getBig delegate. And then we have the main function where we have declared a variable fx of the data type getBig. And next we ask the user to enter 1 for his choice. If he enters 1, then fx is set equal to an expression lambda that takes two arguments and returns the greater of the two. And in the else part, fx is set equal to a statement lambda that takes two arguments and has an expression body consisting of multiple statements. A statement lambda has to explicitly use the return statement for returning its result. And the code is now much simpler. We did not have to define two separate functions. And lastly, we have made a call to the delegate fx by passing two arguments. So the whole point is that our lambda expressions, they have helped us write anonymous functions, and otherwise the things are exactly the same. The system namespace provides built-in delegates that serve our most common needs. So we do not have to specifically define a delegate in our programs like we defined delegate int, getBig, int I, int j. We do not have to do all that. We have already built-in data types, built-in delegates that can be used in our programs. One delegate is called action. The action delegate has more than 15 variants. All variants of action have a return type of void, and that is the only thing that differentiates action from the other type of delegate, which is called func. And this is an example of the simplest action. It takes no arguments and returns a void. Public delegate void action. An example of an action that takes one parameter is public delegate void action in T and T obj. This is generic type, so it can have any type of argument. And let's see the things in action. Consider this program where print square is an instance of an action. This action accepts an int type of argument. We didn't have to define any delegate because this delegate is already defined for us in the system namespace. A lambda statement has been used for writing the function, and lastly, the function has been called. Next, let us come to the func delegates. The system namespace provides various flavors of func delegates also. The only difference between a func and action delegate is that function delegates return a value, whereas action delegates do not return any value. The return type is void. And this is an example of a function delegate that returns a value but accepts no arguments. Public delegate tResult func out tResult. And this is an example that takes one argument, public delegate tResult func in t out result. And now let's see it implemented also. In the same program that we are discussing, we have a get square that returns the square of a number. In the next statement, we use this function to obtain the square of a number, and finally the result is printed. You can obtain the source code from the attached downloads. Thank you.